Hey everyone, we are Group 50, affectionately calling ourselves Team 5050, and in this video we are going to be presenting our project in part of Engineering Team Project 1 for the January 2026 semester. Without further ado, let's get straight into it. Now before we start, let me introduce you to the team. My name is Ruhan Sri Rama. I will be the project leader for this team project. Along with me are Damia, Shuhada, Alya, Qistina, Obert Bunjamin, and Muhamad Asyraf Hakimi.
Flooding is a major and recurrent issue that are experienced by the suburban and rural villagers, especially during the monsoon seasons. When there is a heavy rainfall, the river water level will rise very rapidly, sometimes within just 3 hours, leaving the villagers limited time to prepare and protect their home. Currently, the methods that are used by the communities are sandbags, but it is really inefficient because it is time-consuming and require heavy lifting that are not suitable for people with limited abilities and to the elderly folks. Moreover, many villages lack an effective early warning system to alert them when the water level rises. This highlights an urgent need for a better solution in the flood protection system.
Next, I will explain our proposed solution, which is the hydraulic river barrier. This system is an automatic flood protection mechanism designed specifically for low-lying and riverbank residential areas. It is installed along the riverbanks and remain inactive during normal conditions. In terms of functional requirement, the system operates passively, meaning it does not require any external power. It is automatically deployed using buoyancy when the water level rises, and once the water returns to normal, the barrier retracts back to its original position. Additionally, the system includes an emergency alarm feature. This activates when the water reaches a dangerous level, providing early warning and notifying nearby residents to stay alert and prepared. For the technical specification, the barrier is designed with high durability. It can withstand strong water pressure and resist impact from debris carried by floodwaters. Lastly, the system is low in maintenance and cost. It only requires periodic cleaning and is affordable, making it suitable for rural and developing areas. Overall, this solution is efficient, reliable, and practical for flood mitigation.
Now let's look at the design of the hydraulic river barrier. During normal weather, the system remains in its idle state. As you can see here, the barrier rests completely flat with the riverbank, meaning it doesn't disrupt daily river activities. Beneath the ground, the main chamber remains dry and a galvanized grate keeps out everyday mud and debris. While it sits quietly, our off-grid ultrasonic sensor is actively monitoring the river's water level 24/7. However, when a flash flood occurs, the system automatically transitions into an activated state. As river water enters the inlet pipe, it fills the subsurface chamber. The trapped hydrostatic pressure creates a powerful buoyancy force, naturally pushing the barrier upward on its hinges. Notice that this requires absolutely zero human intervention and zero grid electricity. Simultaneously, the ultrasonic sensor detects this critical water rise and triggers our solar-backed alarm system. The result? The barrier passively stalls the floodwater while the alarm actively encourages villagers to evacuate the area.
Alright, building on what my teammate has explained, my name is Asyraf and I will now present the benefits of our flood barrier based on environmental, social and governance aspects. Firstly, from the environmental perspective, the system has reduced soil erosion and prevent polluted floodwater from spreading into surrounding areas. This helps preserve natural habitats and reduce damage to the vegetation during floods. Next, from the social perspective, the barrier protects people, homes and property from the flood damage. It reduces injuries, financial loss and disruption to daily life, especially during the heavy rainfall. It also increases community safety by giving residents more time to prepare and evacuate if necessary. Lastly, in terms of governance, the system improves planning, safety management and coordination during flood events. This allows authority to respond more effectively and ensure better protection for the public. That's all from me and I will now pass it to the next presenter.
I'm going to talk about some of the major risks involved in our project. Our first major risk involves structural damage. Fast flowing water can carry things such as tree logs, river rocks, and with direct impact can damage the barrier. Another possible cause is the high hydrostatic pressure when water levels are high, which might overload the base of the barrier. To mitigate this, we can make use of a high impact resistance material for the barrier and by adding more structural reinforcement when building on regions that have higher flood debris and flood intensity. The second risk is clogging. In rural areas, debris such as mud or organic waste flowing along a river may block the inlet pipes. As the core mechanism is to use buoyancy to lift the barrier, when water can't reach the buoyancy chamber, the system will fail to deploy. We can mitigate this by including metal mesh to prevent big debris and a dedicated sump to trap finer ones. Then we can establish a simple maintenance plan with the locals to ensure the pipes stay clear and functional.
In summary, the hydraulic river barrier transforms flood defense from a labor-intensive crisis into an automated zero-power response ensuring sustainable life-saving protection for vulnerable rural communities. That is all from us. Thank you for listening.